Hello, everybody. So, I'm Paul. I work as a pen tester at Pentest Limited. Now, a couple of years ago, I was just writing up a blog post based on some research I'd done into Unicode XSS. Most people are familiar with the wide ASCII variant of XSS, but I've been looking into Unicode attacks using combining characters. Now, when you're blogging about a topic like this, it's a really nice touch to include a lab environment that people can experiment with that demonstrates the exact behaviour that you've identified as vulnerable. Now, it's easy peasy to spin up a cross-site scripting lab. There's loads of free app hosting services. But the thing is, XSS, it's not really a user-to-server attack. It's a user-to-user attack. So when you're using a lab environment that just has the server component, there's a little bit missing in that you don't have like a simulated victim. So what would be handy to have is some kind of headless browser system that simulates a victim so you can confirm that your XSS payload actually works on someone else's browser. And it's a bit harder to develop that than it is to develop an XSS lab. And I thought about this, and I thought, well, I can make one. And actually, if I do that, this isn't just applicable to the XSS lab I want for my blog. This is actually more generally applicable. And then I thought, well, it would be really handy if someone could provide a hosting environment where you could just host your custom XSS lab, and then it could benefit from site-wide infrastructure, specifically from the ability to simulate a victim. And I had a look around, and nothing like that existed. So I thought, in the sort of spirit of hacking and the internet and open source and all that I'd get busy and make something. Okay, so here's the site. So what we're looking at here, this is a React front end talking to a Ktor backend. And the key page here is this list of all the labs. So anyone can contribute a lab. In practice, the vast majority of these are ones that I've made. And they cover 3 difficulty levels. So the easy labs go through the basic XSS skills. So I'd expect that like most pen testers would be able to solve the easy labs. And that people who maybe aren't pen testers wanted to learn about cross-site scripting, that's a good place to start. The moderate labs, each one of them, to successfully exploit them, you have to use a specific advanced technique. So I think in experience that pen testers would know some of these, not all of these. If you can learn how to do all the moderate labs, you're going to have pretty sharp XSS skills. And then the hard labs, these are a bit more like research projects in that I would expect that most very experienced pen testers would struggle to exploit the hard labs. Okay, so let's start at the beginning. So the very first easy lab, which is this basic reflective XSS. So when we click into this, we've got some basic information about who's created it, the rating and stuff. There's also a link to a solution video. I realise that while there's quite a lot of content that explains stuff in long form, I just felt it kind of fitted with my educational style to avoid having much written stuff and focus on videos. But the really interesting bit is this button we've got to launch the lab. Now, just one thing to notice, once we click into the lab, we're now in a subdomain. The idea is all the vulnerable functionality is kept in subdomain. So the main xss.uk domain, hopefully, is secure. Also, there's no React here. This is like direct server-side rendering. So I'm figuring most people here are going to be familiar with XSS, but I'll just start from the basics here. So if we just look at what the app asks us to do, to enter our name, and it says hello to us. So this has demonstrated the major component in that there's reflection, there's user input taken, and it's rendered in an HTML page. Now, the next question is, how does this handle HTML tags? And when we look at the reflection, the thing to observe is that italics tag, that has taken effect. We've seen that it's made the text be visually italic. And if we look at the page source, we can see that tag has been reflected exactly as it's been input. There's been no sanitization done. So this is a very strong indicator that there's going to be a cross-site scripting vulnerability. Okay, now, if we just go back to the lab page, we've got an objective here. So run the following JavaScript code. So I can copy that to the clipboard. And what I'm going to do now, inject a script tag. I'm going to paste in the JavaScript payload and close the tag. Okay. And that pop-up demonstrates that we've been able to inject JavaScript into the page. Now, for this vulnerability, the only objective was to inject JavaScript. We don't need to go further and start stealing the user's cookies and doing unauthorized actions. And the other thing that makes this lab particularly easy is if we look in the URL, we can see our payload is right there in the URL. It is a get parameter that is vulnerable. And what that means is to attack a victim, we just take this URL and we send this to them in some manner, if it's by email, by instant messenger, whatever it is, we send it to them, and there's an element of social engineering in that we need them to click this link. Now, for the purpose of the lab site, the social engineering is out of scope. We just take the URL, and then here, we've got the ability to submit a payload. So what that's doing, that's simulating this idea of sending it off to a user and that the user's social engineered to click it. And we can see there that it's confirmed. We've successfully injected that XSS and it's confirmed that we've solved the lab. Okay, now, what I'll show now is how we go about constructing that lab. So we've got this My Labs page here, and we've got the ability to create a lab. So I can create one right now for B-size lids. So there's a whole load of options that control some of the finer behaviour, but we're going to leave all those as the defaults. And you can see here that there's two files that make up the lab. Let's just close our previous tab. And we can preview the lab. We can see we've got a little skeleton. And then we can start customizing it. So if I want to put some custom text in here, I can edit the HTML. And then when we go back here, we can refresh it. So we've got full control. Now, that's just a static HTML page. For the interesting behavior, we need to be dynamic. So the form, it's got this action. So the action is it will send the form data to target.ftl. Now, target.ftl, this is a FreeMarker template. So FreeMarker is one of the leading Java templating engines. It's pretty customizable. So it's both sandboxed and it gives lab writers a fairly free ability to make the lab work how they want. Now, right now, it's just echoing the content back. So this is going to be easy peasy to exploit. In fact, I feel that might be a little too easy for our sample lab. So what we can do is we can now start putting some sanitization in place in the lab. I mean, I could do that and this would be properly sanitized. But what is quite helpful to do is to do sanitization that's incomplete so that people can still attack it. It's just that it's harder than a basic example. So what I could do is use the replace function to remove script. So I'll just save that. Now if I refresh this, we no longer see the payload. And if you look in the source, we can see the bits of the tag that are left, but the script bit has been removed. So we need to do some more advanced technique. Now, there's loads of things we could do, but what is sufficient actually for this example is to use mixed case, because we were only stripping out based on the lowercase script. If we do that, we've successfully got a payload through. Something that's worth pointing out is at this stage, this lab is private. So to access it, you need to have this token in the URL. So some other person can't just come along and look at it. And if you wanted, you could share this with colleagues. But where it gets interesting is when we publish labs to the main labs page. Now, there is one quality control before a lab's allowed to be published, in that the lab author has to submit the working solution. Someone did actually say to me in the corridor before this that there's one on there they thought was not solvable, but I know for it to have been published, the author had to have submitted something, and we are going to go in the backend database and dig out the payload they used. Okay, so we'll take this working payload, and we can submit the payload to the Headless browser from the Lab Manager screen. And now that we've successfully solved it, we can publish the lab. If we look now, the All Labs page, we've got a B-Sides Leeds lab. Now, what I am going to do, because this is just a demo, I am now going to immediately unpublish it. All this stuff is only reactively moderated, so you can just jump on and publish stuff. But if I see something that I think's not in line with the quality of the site, I will, I'll hide it. So back on my labs, and got an unpublish button. Okay, yeah, and it's gone. So that's like the lab creation side of it. Now, I just wanted to show you as well a little bit about how the Headless browser works. So I've got a development environment here. What this does is this drives the browser using Selenium. So we'll just kick this off now. And we'll see it pop up. It's going to submit a payload that causes a pop-up. And then it closes. And if we look at this output here, so the code, it's extracted the flag cookie from the backend. Just incidentally, this flag cookie, every time you access a lab with no flag cookie, you get a random one allocated. So it's quite transparent. So out of this Selenium-driven browser, we've extracted the flag cookie, and we've captured the alert text, and then we've confirmed that the alert text contains the cookie. So that proves that the target JavaScript, it's been delivered and it's been executed in the right domain context. And just to prove this isn't all smoke and mirrors, if I go into the payload here and say there's a typo, when we redeploy this, it might just take a minute to build. We're going to see different behavior. See, it's popped up saying undefined. And if we look at the output, extracted a flag cookie, but the alert text, it's not what it's supposed to be. And so the lab is not successfully solved. Now, just to demonstrate this some more, so if I put that back, now, this was done with like a normal headed browser that interacts with the desktop. But we can pass a headless argument into Selenium. And what's going to happen now is all the same mechanics with the browser is going to happen. It's going to run the payload in the browser. It's going to detect the alert box, extract the cookie, determine success or fail, but it's going to do all that without interacting with the desktop UI. And there we go. The payload's worked. We didn't need an actual desktop. So what I've got is I've got a DigitalOcean VPS just running the headless browser. I figured early on that this was quite a key concern for the robustness of the site. So there's one VPS that runs the web app and a separate VPS that runs the headless browser, and a little microservice that allows them to communicate. And then only registered users can submit URLs. You can only do one every 60 seconds. And it's talking through a proxy. So that headless Chrome goes through a squid proxy, and the squid proxy will only let it talk to XSS domains, not anything else. I do worry that there might be some weaknesses in my lockdown, but it's pretty. I mean, ultimately, even if that server got trashed, it wouldn't actually matter that much. Now that we've got this infrastructure of a headless browser that can prove that the user's successfully exploited the lab, this is really handy because we can now do a bit of gamification based on the successful solutions. So when you solve a lab, you go on the Hall of Fame. I mean, because this is the basic lab, there's tons of people on there. If you look at the more advanced labs, there's only a more select group of people who've got through it. And you get 1 point for an easy, 5 for a moderate, 10 for a hard. And what that also lets us do is that there's an overall Hall of Fame for the top solvers. Now, as we go through the labs, I've had to develop all sorts of functionality to properly support the more complex labs. Now, if we just look again at reflective, now, there's no stored features in this. So each time we launch the lab, we get the same URL. But that won't cut it for doing stored XSS because one person's payload would interact with another user's work. So the way stored works is every time it's launched, you get a fresh lab URL, and any saved state is specific to that instance. It's not shared with the other instances. Now, the next bit that needed more infrastructure was this one. Now, if I just take a quick look at this, so if I inject the script tag, so an initial look at this post-request XSS is that it's trivially exploitable. But the difference is the payload is not in the URL. So we have to work out something that we can send to a victim that they'll click and it will execute. And the way that we do this in the wild is that the attacker would have an attacker-controlled website which they link to and then cause the form post. Now, we've already got all the infrastructure for creating labs, so we can actually leverage this so everyone gets a payload hosting lab. So it's basically the same as the other labs. It's less configurable because most of those options wouldn't be useful. But the core of having different files in the lab URL, that's exactly the same. And what I've created here, so it's a form, and it posts off to the target site. It's got the payload in the form values, and also it's got an onload handler, so that as soon as the page opens, it's going to submit the form and trigger the XSS. So all we need to do here is one click and an exploit. And what we can do is we can right-click and copy that URL and go back to the labs page. So now we're posting in not a link to the target site, but a link to our payload hosting site. But when we run that, under the hood, the exact same thing is going to happen. And then because the headless browser has seen the alert box, we've successfully solved the lab. Now, another piece that involved creating more infrastructure was this lab. Now, the objective is different here. The objective is to capture the cookie. If we launch this, there is a little hint in the rubric that we can use the access log on our payload hosting lab. So if we look down here, there's an access log. And if I just try from my browser, we can see we've got a couple of requests. So again, I'll copy that address. Now, the standard trick for extracting a cookie is to create a new image and load it from an attacker-controlled web server and append document.cookie to that. So if I submit that, well, ostensibly nothing's happened, but we can see from the access log, we've captured a request that contains the flag cookie. Now, at this point, we have only exploited ourselves. So what we need to do is grab the URL, paste it into here. This will send it off to the headless browser. We'll keep watching our access log. And we can see now we've grabbed another flag cookie. If we take that, we can paste it into here, and we've successfully solved the lab. So there's all sorts of functionality here to support all sorts of advanced cross-site scripting scenarios. So we've been through like stored payload hosting lab and the access log, the support for raw sockets, custom headers, URL rewrites, and there's loads of functions for doing things like stripping of HTML tags, extracting metadata from JPEG images, all that stuff to make it possible to host like really sophisticated labs, which is what the moderate and hard sections rely on. And just to give you a little teaser, all that time we were logged on as a demo user, and I've got an admin user as well, so we can, for example, have a nosy at the payload. So, okay, a lot of these just now, this is the demo I was doing just now, and this is, I think, me practicing last night, but you can see there's other users submitting things. You can see when it's worked. I can see. By the way, if people get to 100 score, I don't always do this, but and I've had some communication with them, I normally give them access right to view the payloads. so it's been a load of fun making it. I guess I'd say as a little call to action and come and get involved. I'd love for more people to submit labs. I'd love for some people to submit third-party solution videos, because right now it's just me and people are probably sick of my voice. One area that I've not explored at all and could be a lot of fun is labs that rely on specific vulnerabilities in JavaScript libraries. There's all these things like version x.y of jQuery UI. It would be quite cool to have a whole section that targeted outdated JavaScript libraries. And beyond that, couple of things I've got in the pipeline. I do want to create a CTF mode that would be for use in person at conferences, so you could get into teams and have a team score, maybe do it timed. Not figured out exactly how that would work. And then, although I've boxed myself in a bit with the name of the site, I do want to add SQL injection to this. It would be really cool that you could just spin up a virtual database and a bit of app code that had particular vulnerabilities. And just like how the headless browser is off on a separate server, I just have the vulnerable database off on a separate server from the main app. So that's me. I hope that was useful.